Today we're going to start talking about postulates and paragraph proofs. We're going to actually use the logical statements that we've used, that we've created and learned about, conjectures, conditional statements, and we're going to start creating these postulates that we're going to build our geometric system on, or Euclid built his geometric system on. And also we're going to talk about paragraph proofs, which is a type of proof in order to create theorems. Remember that postulates are assumptions, are axioms that do not require proof. Theorems require proof. They are statements or conjectures that require us to prove them. So we're going to begin to prove some theorems and create some theorems. First, postulates, we've already been through some of these, and they're just a logical conclusion of extension of what we've talked about in the first chapter. Definitions of undefined terms, points, lines, and planes. First 7 postulates that we're going to build upon are, number 1, through any 2 points, there is exactly one line. How many points does it take to describe a line? 2. Through that any 2 points, there is exactly one line. Number 2, through any 3 points not on the same line, that's 3 non-collinear points, not on the same line, there is exactly one plane. How many points and what type does it take to describe a plane? 3 non-collinear points. Okay, number 3, a line contains at least 2 points. Well, that's sort of like the converse of number 1. If through any 2 points there is a line, then there is exactly one line. If there is a line, then it contains at least 2 points. So those will be converses. 1 and 3 will be converses of each other. 4, a plane contains at least 3 points not on the same line. A plane contains at least 3 non-collinear points. That would be the converse of number 2. Number 5. If 2 points lie on a plane, in a plane, then the entire line containing those 2 points lies in that same plane. Simply saying, if you have 2 points in a plane, those 2 points describe a line, that entire line is also in that same plane. Number 6, if 2 lines intersect, then their intersection is exactly 1 point. Number 7, if 2 planes intersect, then their intersection is a line. Now, from these postulates, we're going to begin to establish and prove and talk about theorems. Okay? Theorem is a statement or conjecture that requires proof. Now, once that statement or conjecture has been proven, then we can call it a theorem and use it. All right? Let's take a definition of a proof. I will be passing out information to you, notes that will contain these seven postulates, so do not despair in writing them precisely. However, you will need to know them. Exactly what is a proof? Definition. Proof. Get it down exactly. Is a logical argument in which each statement you make is supported by a statement that is accepted as true. Now, number one, what kind of statements are those? Well, postulates are those statements. So those 7 postulates are assumptions or axioms that are assumed to be true. What else are statements that are accepted as true? Once a conjecture has been proven, then we can accept that conjecture as a theorem, and we may use that theorem without proving it again. So a proof is a logical argument in which each statement you make is supported by a statement that is accepted as true. Okay, what we're going to do is we're going to take a few of these and go through. Number one, we're going to prove the first theorem in our list, which is the midpoint theorem. And we're going to set this up and draw a picture and go through this proof. We'll go through a paragraph proof pretty quickly, and then we'll do some examples of other proofs. In a proof, when you're doing a proof, you always have a given, and then you're asked to prove something. So in this given, we're going to be given information. Now the given is going to be your hypothesis. M is midpoint of PQ, segment PQ. They want us to prove PM, segment PM is congruent to segment MQ. Okay? Now, our first comment is going to be from the definition of midpoint. We know that the measure of segment PM equals the measure of segment MQ. This means that segment PM and segment MQ have the same measure. Okay? Now, what do we know about segments that have the same measure? Okay. The definition of congruence states that two things that have the same measure are congruent. Therefore, segment PM is congruent to segment MQ. All right? Let you look at it. Read it. See step by step. Each one of the sentences is required for us to prove that a midpoint creates congruent segments. Given M is the midpoint of segment PQ, prove that segment PM is congruent to segment MQ. From the definition of midpoint, we know that PM, the measure of segment PM, equals the measure of segment MQ. This means that segment PM and segment MQ have the same measure. The definition of congruent states that two things that have the same measure are congruent. Therefore, segment PM is congruent to segment MQ. We have just proven what is known as Midpoint Theorem. And because we have just proven that, we can now use it and say, oh, by the midpoint theorem, we know that what? A midpoint creates congruent segments. Okay? All right, let's do one other sample. And one of the things that we use in doing these theorems and proofs sometimes is some good old algebra properties. And some of those are symmetric, reflexive, and transitive. If you remember, symmetric has to do with, actually reflexive has to do with oneself. I look in the mirror, I see myself. I am equal to myself. A number equals itself. 1 equals 1, A equals A. Symmetric is if 1 equals 2, then 2 equals 1. If A equals B, then B equals C. My twin and I look like each other. Identical twins look like each other. And the transitive property says, oh wow, if A equals B and B equals C, then A has to equal C. Identical triplets look like each other. If Tom looks like Harry and Harry looks like Dick, then Tom looks like Dick. Okay? That's Tom, Dick, and Harry transitive property. So we're going to be using that in proving these theorems. Now, in the next one, what we've got is we've got a given. Given that angle A is congruent to angle D. And we're also given that angle D is congruent to angle E. Prove angle A is congruent to angle E. Okay? All right. If angle A is congruent to angle D, then we know that the measure of angle A equals the measure of angle D. If angle D is congruent to angle E, then we know that the measure of angle D equals the measure of angle E. Okay? So, by the transitive property, if measure of angle A equals the measure of angle D, and measure of angle D equals measure of angle E, then measure of angle A equals measure of angle E. By the definition of congruence, then angle A has to be congruent to angle E. Okay? Let's look at it. Came in and said, if those two angles are congruent, we know that they have the same measurement. If these two angles are congruent, we know that they have the same measurement. Notice we use a conditional statement. And by the transitive property, we know that if measurement of angle A equals measurement of angle D, and measurement of angle D equals angle E, then measurement of angle A equals measurement of angle E. By the definition of congruence, anything that has the same measurement is congruent. Therefore, angle A is congruent to angle E. Okay? This is what a paragraph proof looks like. Let's take another. Okay? Because you've got some of these to do, homework, and these are some samples that are on some of the things that we passed out. So I'll let you look at them. Given segment BC is congruent to segment EF. Okay? M is the midpoint of segment BC. N, get this up there, right, is the midpoint of segment EF. Prove that the measure of segment BM equals the measure of segment EN. Now, let's draw a little picture over here. Okay, we have two segments. We know that segment BC is equal to segment BN. We know that M is the midpoint of BC. We know that N is the midpoint of EF. Okay? So, here goes our proof. Because M is the, and I'm going to abbreviate this, midpoint of segment BC, and N is the midpoint of segment EF, we know that 1/2 of the measure of segment, let's do this, we know that the measure of segment BM equals 1/2 of the segment, measure of segment BC, and EN equals 1/2 the measure of segment EF. Okay? Now, we know that segment BC is congruent to segment EF. Alright? Well, if segment BC is congruent to segment EF, which is true, then BC equals EF, all right, by congruence. Okay? And 1/2 BC equals 1/2 EF. By another algebra property we know called the multiplication property. Multiply both both sides of an equation by what? Something. As long as you do it together. Therefore, Bm equals En by the transitive property. Okay? Let's look at it. Given segment BC is congruent to segment EF. M is the midpoint of BC, segment BC, and is the midpoint of segment EF. Prove that the measure of segment BM is equal to the measure of segment EN. Here it goes. There's our picture. Because M is the midpoint of BC and N is the midpoint of EF, segment EF, we know that the measure of segment BM equals 1/2 the measure of segment BC, and the measure of segment EN equals 1/2 the measure of segment EF. Because segment BC is congruent to segment EF, then we know that this measure of segment BC equals the measure of segment EF by the definition of congruence, and 1/2 of the measure of segment BC equals 1/2 the measure of segment EF by the multiplication property. Therefore, the measure of segment BM equals the measure of segment EN by the transitive property. Welcome to proofs. Paragraph proofs are not the most fun to write because you have to write complete sentences and complete thoughts. I like formal proofs because all we have to do is state the given and the reason. We make our statement and we make a reason. We'll do those here shortly, early next week, and do them. Okay? Study these over. You've got some homework and some practice that involves each one of these.